There it is. Wow.
So serendipitous.
That's
and
the original one right there.
That's the first X-ray of a human
God, that
body
even
part.
looks like pretty good today.
That was the first Nobel Prize too in physics, and that was part of the Nobel Prize desire was to create things that would have a beneficiary effect on human flourishing. And I'll show you some of the videos.
Yeah, we'll free plug while we're at it. Let's
exactly.
go.
That's right. Why
That's
not?
what we're here for,
all I'm paying for.
That's what I use my platform for.
That's
Free
right.
plugs.
Not for these cranks like.
I'm even just blown away by that picture though. I love looking at stuff like that.
That's beautiful.
So what video are you looking for, Brian?
It's in the playlist. Go to videos, Joe, and then click on the second one. Rubin's first data. There it is.
All right, hold on. Let me turn this volume on so we can hear it.
See. Oh, you're not subscribed. Oh, so there you go. Hit
That's
the
not
there
my
you go.
account. That's
Boom.
his account.
All
yeah,
right.
Just want to
Now
be
give
clear.
it a thumbs up. There you go. Thumbs up.
Can we hear that from your speaker, Joe?
Hey,
Is that what we're doing? Let me just make sure I got it here. Let it rip.
What you're about to see is an exclusive interview
There's
from
the
the
camera.
leaders of one of the most exciting observatories ever built, the Vera Rubin Observatory. In just 10 hours, you captured over 2,000 asteroids, which is something like 100 times faster than the discovery rate around the whole planet. Some of these asteroids could be Earth killers, and that same technology is set to revolutionize our understanding of dark matter, peering into the massive Virgo cluster with
So pause it there.
unprecedented
Go back,
clarity.
Joe.
When you finally
So what I show, go back to where I said the Virgo cluster. Go for it a little, yeah.
Which is something like 100 times faster than the
We'll talk about the
rate
asteroid
around the
discovery
whole
ratio, 'cause
planet.
that's
Some of
really
these
important.
asteroids could be Earth killers, and that same technology is set to revolutionize our understanding of dark matter, peering into the massive Virgo
Pause
cluster.
right there. Okay, so this is the first cluster that they looked at. What you're seeing here, the things that have like crosses on them, those are stars in our galaxy. Everything else that doesn't have a cross on it is a galaxy in another part of the universe. Some of these are like 50 million light years away from the
50
Earth.
million light years away, and we can see
And
it.
we can see them, and we can see if they're moving, and we can zoom in on them, which you can do. There's a tool in the video description called Skyview app or whatever, and you can zoom it. This image is just like the first image that you get, and it's like a telephoto lens. This image he showed me when we did the interview with Mario Urich. You can zoom in on a galaxy and basically do it like a 200 power telescope, but you can do whatever you want with it. All this data is free. It's available to the public. They're not hiding it. They're not saying, oh, there's some classified information there. And some of the information that I can detect, the thing I led off with, is that in 10 hours, it discovered 2,000 asteroids. Now, why is that important? Well, a lot of these were discovered, they were never known. And some of these could eventually be something that could threaten the Earth. So they have tracked, and he goes on to talk about in the interview, he's one of the leaders of the time domain, which looks for things that are basically making a movie of the universe. So it's the first time we've had a dynamic telescope. Literally, it's the first time we've had a video camera on the universe with this sized type of telescope, with this resolution. So it can do anything. And the coolest thing about it is that anybody has access to it. It's like you have your own 8-meter diameter telescope. It's bigger than this building.
When I hear something, though, like, what'd you say is 50 billion light years away? Is that right?
Million.
50 million. Either way.
Yeah, that's right.
Like it's that doesn't even process for me like how we have created something on this earth where we can actually see that.
That's right. That's one of the beautiful things about science, which is why I'm such a huge proponent and cheerleader of it, unabashedly so. And I believe it should be protected and kept. These were not built by people who were like, in order to have like some wild-eyed idea, like there's no person, Einstein, 1,000 Einsteins working in isolation, as smart as he was, could not have done this. It took the cumulative efforts of thousands of people, millions of dollars. It's not quite $1 billion experiment, but it's millions of dollars, and it's built up over time in order to focus, no pun intended, on serendipity. So serendipity is the one tool we have in science to guard against confirmation bias. Imagine you're not looking for something, but you find it,
Right.
versus if you're looking for it and you find it.
That's right.
So that's what happened with the CMB, the cosmic microwave background, which is my area of expertise, was found by accident. Remember, I said they were looking for a communication satellite with excess noise. It has nothing to do with the Big Bang. They didn't even think it had, they didn't know what they had discovered. They had to ask scientists, theorists, and others to collaborate with them. And they were trying to win their own Nobel Prize, these other guys, including my PhD grandfather, my academic grandfather. And so the point is, when you do these measurements, you don't know what you're going to look for if you do a measurement and you're not trying to find something. that in some sense is the purest thing you could possibly discover. Like penicillin was discovered by accident. A guy left out some cheese or some mold, and he discovered actually the bacteria won't be capable of digesting it. It acts as a toxin to them, and that was then developed into penicillin. It wasn't saying like, let me invent this thing that will then be used to cure as an antibiotic. The X-ray was invented basically accidentally. This guy William Röntgen,
Really?
he was experimenting with just like electrons in a tube, and then he noticed that he had a piece of film in the other room, and the film kept getting exposed, and it had this pattern of the case that it was in. Then he took his wife and he said, honey, put your hand here. And then he fired the electrons in this tube at her hand, and she saw her bones. The first X-ray in history. If you look up Röntgen X-ray, I think her name was Martha.
I always wonder what it would be to be like a fly on the wall in a room like this. Like, holy shit, don't move. Don't fucking move. We are never having to pay our mortgage late again. There it is. Wow.
So serendipitous.
That's
and
the original one right
that's
there.
the first X-ray of a human
God, that
body
even
part.
looks like pretty good today.
That was the first Nobel Prize too in physics, and that was part of the Nobel Prize desire was to create things that would have a beneficiary effect on human flourishing. And in fact, it has. I mean,
Yes.
anyone who's had a tooth pulled, knows how important it is to have an X-ray. So if that's Vera Rubin, it's going to revolutionize our find things serendipitously. It'll find things intentionally, like it's looking for asteroids. So it's not, but what if one of those asteroids on a collision course to prevent the Earth from getting destroyed? We got to call Bruce Willis and get him out there, right? So this is part of the
Don't forget Ben Affleck.
Ben Affleck, that's right. So we get all these serendipitous benefits from all these types of tools and technology. Now, dark energy, which you should pivot to, is a completely different thing. So dark energy is an invisible energy, and so in that sense, it's invisible. So it has that similarity to dark matter, but it acts completely differently. Matter tends to only gravitationally attract. That's what's weird about gravity versus the other forces. Electricity, positive and negative charges.
Right.
Magnetism, north and south magnetic poles. They can attract or they can repel, but gravity only attracts. It's weird. But there's something effectively called anti-gravity, which is real, but it's incredibly weak and dilute, and that's what dark energy is. Dark energy is like a repulsive form of gravity that causes the universe to expand, to inflate, to get bigger every day, and to get bigger at a faster rate as time goes on.
Why is that anti-gravity? For it to expand the universe?
So in Einstein's theory of relativity, when you add in energy into empty space, the empty space effectively is causing repulsion, gravitational repulsion. It almost acts as if you have two like charges together. Remember I said gravity acts as if it's always has two different charges, but there's only one type of charge. That's just this mass, right? There's no like anti-mass and mass, but all mass attracts as if one was positive and one was negative, but that's just because gravity itself is universally attractive. But if you have pure energy that suffuses space itself, the space can get bigger without the matter within it getting bigger. So it acts as if it's like blowing up air pressure inside of a balloon or tension and stretching out a rubber band or something like that. It acts as if it's repulsive gravity, and it has appeared as since the time of Einstein. So in 1915, when Einstein came up with his law of general relativity, 10 years after the speed of light, special relativity, he came up with a law that described how the universe as a whole could be expanding or contracting. But he observed at the time they didn't know of anything that was expanding or contracting. They thought the universe was static at that time. So in 1915, the model of the universe was that the universe was eternal. And so nobody believed that the universe was, and actually that's all the evidence showed. When you look at a star, the only things that move in space are the planets that we could see, planets and asteroids. We can't see the galaxies moving unless you had a very powerful spectroscope.
So why did they say the universe was internal though?
Was eternal?
Yeah.
Because if it's not changing, the notion is that it has always been there that way. It didn't need to have a creation, didn't need a creator. It didn't. There were a lot of biases against the kind of Big Bang narrative at the time. But actually, the Big Bang model was proposed by Lemaitre, this guy who was a Belgian Catholic priest in the late 1920s, that actually, no, the universe should be expanding. Einstein didn't believe it, and he put into his laws of physics, he put in this fudge factor called the cosmological constant, which was, in order for the universe to remain stable and static, he had to prevent the gravitational collapse of the matter that he could see with his eyes, stars, planets, etc. He knew there was matter, so there had to be something keeping it from collapsing, or else he wouldn't be there asking the question of why the universe wasn't collapsing. So he put in this thing. He later called it his biggest blunder. It's called the cosmological constant. And what has been known since 1998 was that he was actually right that there should be a cosmological constant, but it doesn't keep the universe static and it doesn't make the universe contract. It makes the universe expand.
Thank you guys for checking out this clip. If you haven't already subscribed, please subscribe and hit the like button on this video. It is a huge, huge help. And if you'd like to check out this clip's full podcast episode, that link is in the description below or right here. And finally, you can follow me on Instagram and X by using the links in my description below.